Okay, let's go ahead and get started. And hello, everyone. Welcome to The Current. This is the North Central Region Water Network's Speed Networking webinar series. I am Rebecca Power, joining you from the University of Wisconsin-Madison Division of Extension, and I will be moderating today. The North Central Region Water Network is an extension-led collaboration among 12 universities and our partners in 12 upper Midwestern states. So great to see the diversity of folks joining us today as you all pop in here. Our topic today is winter manure application water quality. Perfect seasonal timing. Go figure. I'd like to think we planned this, and we did. So great to have everyone joining us. As you know, winter manure application has a lot of logistical benefits and can have some financial benefits, can have some agronomic benefits. However, it can create problems for water quality and spring runoff. So we have three folks joining us today to talk about the relationship between winter manure spreading and water quality, what we know and what we are learning. With that, I will, logistics for today in our webinar. So as we get started, you can submit your questions for presenters in the Q&A panel. We'll have a dedicated Q&A session after all three of our speakers are through. That Q&A panel can be found via the Q&A icon at the bottom of your webinar screen. If you are experiencing technical difficulties, you can, or have questions about the North Central Region Water Network, you can use the chat feature. So questions for our presenters in the Q&A, anything else, ask in the chat. And that chat feature is also accessible at the bottom of your screen. If you're having audio issues, there is a phone-in option, so you can click the up arrow on the mute icon or the little microphone icon and select switch phone to audio. We do record these sessions and they are available at our website, northcentralwater.org. And we do live tweet these events when we can. So feel free to chime in if you're learning some things that you think other people ought to know about right away. All right. I'm just having a couple things here that it's asking me to do. All right. Okay. So on to our speakers. Today's presenters are Dan Anderson, an associate professor of Ag and Biosystems Engineering at Iowa State University. He is going to be talking to us about winter manure management, the science and perspective behind best management practices. Melissa Wilson, who is an assistant professor at the Department of Soil, Water, and Climate at the University of Minnesota. And she's going to be talking a little bit about liquid versus solid winter applied dairy manure. And then finally, Todd Troyan from South Dakota State University will be talking about winter manure application and water quality research, some new research that he's got going on in South Dakota. So we're trying to cover the range of the region here. And with that, you want to hear more from them and less from me. So we'll go ahead and get started with Dan Anderson. He is an associate professor in Ag Biosystems Engineering, and you can read a little bit more about him here on the screen. He focuses on sustainable ag practices related to carbon, nitrogen, and phosphorus cycles and has a related extension program. So with that, I will stop sharing my screen and turn it over to Dan.
All right, thank you. Winter manure application is always fun to talk about. I get to train manure applicators in Iowa, and one of the favorite questions that I get every year is, can we put manure on in the winter, and what would you tell us to do? So that's what I'm going to try and talk to you about today, some of the things we tell them. Okay, so the first thing, I think there's lots of reasons why we might want to put manure on, and I think it's important for us to recognize what producers are trying to achieve when they do that. Because as we think about some of the opportunities and challenges we face as we try and maybe move manure away from winter towards more in-season application, certainly there's some challenges and questions. And one of them that I think we maybe can't get away from is emergency application. That is always going to be a part of manure management. Hopefully not a major part of what we do, but certainly every year in Iowa, we'll see some broken water lines in a barn. The pit fills up fast, and in that sort of emergency, we definitely would rather see some manure make it out to the field rather than watching the pit overflow, right? So even in those situations, we're going to have people asking, what's the best options for me? A big one around here is we have a lot of poultry farms, and they take large solid manure spreaders across fields, and there's a lot of discussion about compaction, and frozen soils just don't compact, right? So I mean, there's opportunities there, and that is one of the things that as we push towards more in season, a lot of the pushback we get comes from that compaction discussion. Certainly timeliness. Fall and spring can be extremely busy with harvest. Moving that labor demand to a different season can be good. I get a lot more odor complaints in spring and summer than I do in winter. Most of these people aren't outside, so some farms see that as an advantageous opportunity. And then I'm going to try and talk just a little bit about bacteria. And bacteria is an interesting story because some people think there's lower bacterial survival with winter manure application, and some people say it's enhanced in the winter, and we'll try and look a little bit about what the science is behind that. Okay, so why wouldn't you apply manure? Well, in Iowa, for liquid manures coming from medium or larger size confinement animal feeding operations, we have state laws that say you can't put manure on frozen or snow-covered ground between certain dates, right? And I think a lot of people run into that sort of issue if you have an NPDES permit, right? So we have some of those, not a lot, but some here in Iowa, or a comprehensive nutrient management plan that bans it. And specific farms, I think it's important for us to recognize that whether they are or aren't putting manure on in the winter, and the opportunity to do so can be driven by some regulations that we have. There's a lot of other reasons why we might have struggles with putting manure on in the winter. And the big one probably is an increased risk of nutrient loss. And that's the way I like to phrase it as I talk about it, is a risk. I think we're going to see some great research today, and I'm going to review some research that I looked at between 1935 and 2008, and it really comes down to that. It's risk. Just because we put manure out in the winter doesn't mean we're going to lose a lot of nutrients. It comes down to what happens with the weather, and that sometimes is hard to control, right? We get the season we get, but knowing that there is more risk involved certainly can be useful. So I tried to look back at the history of frozen ground and snow-covered ground manure application. I identified 11 studies between 1935 and 2008. And as we look from 2008 to the present, there's actually quite a few more studies that have been added to this that look at a lot more specifics. So I'm going to try and generalize it. So I'm looking at some of the older research that is out there. When I looked at those 11 studies, one thing that rang true is catastrophic events drive the majority of nutrient transport. In particular, there was a study by Jeff Lormore done here in Iowa. He had winter manure application over 4 years. He put it on, hopefully before it snowed was his goal, and then once again on top of snow-covered ground. In 3 of those years, he had basically no nutrient movement coming off his fields. However, in the 1 year that he did have nutrient movement from his field, it was a rather large snowmelt event that happened extremely quickly. He estimated he lost somewhere around 12 to 25% of the nitrogen and phosphorus he applied, right? So that is a large loss of nutrients coming from a field, a catastrophic event that drove a lot of that nutrient loss. The other thing that I think generally rings true off most of these studies is that runoff events soon after application pose the higher risk. And one thing we can take away from that is if we are doing manure application in those winter months, applying early in the winter is much better than applying late in the winter. Especially as I look at my Iowa climate, if I would apply in late December, early January, I tend to not have as much snow cover on the ground. Certainly I might have some, but not as much. And the runoff events are much slower. When I get sort of that late February, early March window, if I'm putting manure on the ground, I can lose a large amount of that snow cover very rapidly. It might only take a day or two rather than slow melts over a week. There's a lot of discussion in the literature about the impact that land slope may or may not have in increasing the risk. I think generally they suggest that zero slope is best. And I think that makes sense to a lot of us, right? Less slope means any runoff water we do have tends to have less velocity, and it will scour less of those manure nutrients that have been left on the surface. I do want to point out that oftentimes we think frozen ground, nothing's going to get into that soil. That isn't always true. Frozen ground does not necessarily mean zero infiltration. And when we're thinking about winter manure and the risks that it has, following that water really tells us a lot about where those nutrients may be partitioning. And I'll take a little more detailed look at that on my next slide. And then the last one is snow. Manure under snow may or may not be better than manure on top of snow. And that one's sort of surprising to me, because one of the things that I like to tell farmers is get our manure nutrients in contact with the soil, right? Soil is our friend. If we can get the manure to touch the soil, phosphorus loves to stick to soil. Ammonium generally likes to stick to soils. So contact is a good thing. However, in some situations, that doesn't always work the best. Putting manure on top of snow, if it causes that snow to melt relatively slowly and the water can infiltrate in the ground because we have the right soil structure to do that, doesn't always result in increased risk. So that one is interesting and a little contradictory to what we might sometimes expect. All right, one of my favorite references for hydrology of frozen soils comes from 1955, and they identified 4 different soil structures, right, that can occur for frozen ground. And he called them concrete, honeycomb, stalactite, and granular. And I wish there were pictures in the original manuscript of what he meant by each of those terms. Unfortunately, I couldn't find them. The important thing that is pointed out, though, is that 3 of those, the honeycomb, stalactite, and granular, all encourage infiltration of that water, even though the soil is frozen. It's that last structure, the concrete structure, that really is the dangerous one. And there's a few things that lead to forming that concrete structure. And the concrete structure is really exactly what we sound, right? That soil that looks a lot like concrete and is froze hard as a rock. One of the big contributing factors is how wet is that soil at the time it freezes. Wetter soils will form that concrete structure much more readily than drier soils will. And the other thing he pointed out, and that probably makes a lot of sense, is freezing and thaw cycles help contribute to that concrete cycle. And that occurs because, especially for wetter soils, if soil pores are filled with that water, as that water freezes, the ice expands and it basically breaks up the aggregates, right? So if we lose our aggregation structure, it's a lot harder to get water to move into the soil. So one of the things that people have said from this is, again, try and apply early in the winter before that soil structure is challenged from the freeze-thaw cycles. Freeze-thaw, from my perspective, is a lot bigger issue down here in Iowa than maybe as we move north, it might actually maintain a frozen soil all winter, but it's something that we steadily deal with throughout the winter here. And then the other one is try and look for fields where there's a better chance of maintaining structure. And that means finding fields with living roots, or at least dormant roots. And that could be grass fields, alfalfa fields, or even probably cover crops that would increase aggregation of the soils and help maintain some of that structure throughout the winter. When we look at the results, and there are fewer studies that have looked at bacteria, but when we look at the results for bacteria, E. coli survival is generally better in cool water than warm water. However, if we reach freezing conditions, most of the time that is lethal to E. coli. So in some ways, if we have bacterial concerns, potentially winter manure application might be able to help with that. On the other hand, there are numerous types of bacteria, some that can resist freezing, Cryptosporidium being one of them, where it's known that they will survive well even below freezing temperatures. Okay, so I'm going to try and summarize some of the things that I think we can take away from these. What we know is that if manure nutrients are exposed to runoff water, they're going to move through the field more easily. And that risk is dependent on snow depth and the weather. And what I like to tell the farmers that I talk to is this really isn't rocket science, right? We can complicate it as much as we want. But the truth is it's not rocket science, and it's probably not even model rocket science. We know that that manure application in the winter is going to be more risky than other seasons. Now, that's not to say that other seasons don't have their risk as well. The future weather conditions, the hydrology of what happens after we put our manure on the field is extremely important. If we get a 5-inch rain, a gully washer, it's going to wash off some of those manure nutrients. Just winter makes that much riskier for what we're doing. So if you can, incorporate manure, right? Getting manure into the soil is always our best option. Certainly when we really look at real winter manure application when we're frozen or snow covered, that gets much more challenging. I have seen up in Northwest Iowa, someone snow blow a 40-acre field so that they could get the manure right in contact with the soil surface and do a winter application. I think that is often logistically challenging, but it is something I've seen someone try. And sometimes if we can get an early snow, that'll help insulate some of that ground and we can still run incorporation, actually get reasonable levels of incorporation early in the winter. The other one is avoid areas of concentrated flow, especially places like waterways or places in fields where waterways could or should be. In Iowa, many of our fields have relatively little topography, so micro depressions tend to be areas where we get a lot of winter flow, and it might not have a true waterway in it, but those are also areas that concentrated flow does occur, and we'd rather have that manure high and dry. The other thing to look for is apply to land with low runoff risk. In particular, one of the things that we use in our regulations is we use a phosphorus index, and in order to do winter application, we encourage you to find fields that have lower phosphorus indexes, because that will identify fields that have less potential for washing of nutrients that are left on the soil surface. Those tend to be relatively flat fields, or at least relatively low tilled fields where we have more residue. The other thing to look at is that snow accumulation total. That's really our driver for nutrient movement, right? So try to look for lands that accumulate less snow. And that one gets to be a complicated recommendation because in some cases I can run into things that are a little contradictory there. Specifically, residue may help or hurt us. Oftentimes, when I drive around the countryside in the winter, the fields that tend to have the most snow accumulated in them are hay fields that have either alfalfa or grass in them. From a residue risk of soil movement, they tend to be better, but all that snowfall can make it worse from a hydrology standpoint because that snow stays in the field. The other thing that is important is to recognize and follow setback distances from stream banks, sinkholes, and hopefully try and make those setback distances larger than normal. While frozen soils don't always have no infiltration, oftentimes it is reduced. One of the things that we deal with a lot is surface tile intakes in many of our fields. Those are located in the depression areas. And for winter applications, we strongly recommend that we sleeve or cover those surface tile inlets for a couple weeks after a manure application. So right here, you can just see we're putting a piece of PVC pipe around a surface inlet just to have it sleeved so that it can't take that water without having the water contact the soil at least to some level, rather than having a direct conduit away from our field. We do want to try and apply when significant runoff events are less likely. And I think forecasts, while not perfect, can really help us in there, right? So we're looking for times when we have extended periods where the weather will work in our favor, especially avoiding any of the late winter rainfall events where the risk of nutrient movement is extremely high. And we also want to look for time periods when, if we do have that snow cover, melt will be less rapid, right? We want slow melts where it has a chance to infiltrate into our soil. We're looking here at a field in this picture where I was driving through Iowa one day, and I know that field had manure in it because you can see nice brown water coming off the field, but we're getting enough snow melt, a rapid enough snow melt that we can see that concentrated flow. So the things that we really want to try and do is locate fields that are going to be high and dry, right? Fields where we have a nice footprint in terms of not probably being saturated in the fall when our soils got frozen. So we have a soil that's better to infiltrate, and avoiding those portions of the field where we will have concentrated flow. So if you need some contact information, there you go. And our presentations will be available later, but I do have a couple slides of references to see where I was pulling some of that guidance from. So with that, thank you for your time.
Sweet. Thank you, Dan. And I have to say, I love the fact that you started out with some "it depends" kinds of things, but then you focused in on like the so what, like, okay, so what do we do with this? It depends. So thank you so much.
That is the perfect extension answer though, right? It always
depends. I know, right? I was like, okay, it does. And it does. So we know every farm, every field is unique. So thank you so much for that. All right. I'm going to go back and share my screen here for just a minute while we introduce Melissa. All right. So our next speaker is Dr. Melissa Wilson, and she is at the University of Minnesota. And funny thing, her research and extension program also focuses on manure and water quality. I will say, and Anne put a note here in the chat too, so you can also upvote people's questions. So as you have questions for our presenters, put them in the Q&A panel. And then that helps everybody else on the participating in the webinar upvote those questions that they think are most helpful to make sure that we get those questions answered. So with that, I will stop sharing my screen if I can. And Melissa can start sharing hers. So thanks so much.
All right, can everyone hear me okay?
Sounds good.
Great, thank you. So thank you so much, Dan, for that great summary of kind of things to think about when applying winter manure. When I first came to Minnesota, one of the first things we did is wanted to see, does all that old literature still hold up, especially in Minnesota, where we're starting to see a lot more of these freeze-thaw cycles throughout the winter, rather than just it freezing solid in December and then maybe in March we'll get lucky and it won't be frozen anymore. Like today, for instance, you know, we're getting these more events where we're seeing these thawing times. So we wanted to see if there was a difference between liquid versus solid. And by solid, I'm talking about like 15 to 19% solids for dairy manure, which is something that's kind of a little drier. It's sometimes stackable, sometimes not stackable, but definitely much more solids content than some of our liquid manures. So what did we do? Well, we took a dairy manure and basically diluted it to various solids contents for this study. So that way we're at least getting, you know, from the same source and then seeing if more liquid versus more solids makes a difference. We then went and applied it on top of snow and measured the nutrients in runoff. So on this, we were doing about a 2% slope. So it was not drastically sloped, but it was sloped enough that we would get some runoff during these thaw periods. Did this over 3 different locations in 2018 and 2019 near St. Paul, Minnesota on our on-campus farm fields, and also in Marshfield, Wisconsin. And we both used our own dairies. We have an on-campus dairy and they have an on-site dairy in Marshfield as well. So we used our own dairy manure and then diluted it down. Here's some photos from our experiment in 2018. Our high solids for all of the sites ranged from 13 to 19%. And then we diluted it down in Wisconsin. They also had a medium solids, which was about 8%. And then in Minnesota, we did a low solids, which ranged from 3 to 5%. And then we always had a control that did not have manure applied on it. One of the interesting things that we noticed right away was that the solid manures definitely like sat on top of the snow and then slowly melted down. Whereas with the liquid manures, they sunk into the snow almost immediately. You can actually see it starting to travel here through the snowpack towards the runoff point. So that was kind of just an interesting observation that we saw right away. Just to show some quick pictures of the first year that we did this study. Here, this is after our first snowmelt event. We actually got manure applied right before our first event in late January. So the manure was applied on January 24th, and then our first runoff event was January 28th. And you saw the first pictures where we applied the snow. Like we had a lot of snow and there was a lot of melting that occurred within that 4-day period. So this is, in this case, this is 19% solids. And you can see how dark the water is. Dan kind of talked about how he drove by a field and saw the dark water. Even at 3% solids, we saw pretty dark water versus where there was no manure applied. You can see some sediment had washed off, but we are seeing very clear water otherwise. And then we had another rainfall event on top of snow in early March. And at that point, this is what the runoff water looked like. You can still see a lot of that dark color still in our solid manure plots versus the liquid manure plots looked a lot clearer. It was very similar to what our no manure plots look like. What was interesting though is when we lifted up the lids that were on top of the collection systems, you could still smell manure in the liquid manure plots, but you just couldn't see it anymore. So again, just kind of an interesting observation. So I'm going to show you first the concentrations that we saw. So the milligrams of a nutrient per liter. In this case, we're doing inorganic nitrogen first, which is the combination of ammonium and nitrate. So the first graph shows you Minnesota in 2018, and this is over the whole winter season until snow was gone. Minnesota 2019 and Wisconsin 2019. The control is always in like this lower bar here, that's the darkest red, and the high is always in the yellow bar in all of these. And then the low is the lighter red and the medium is more of a gray color. One of the interesting things that happened is in 2018, we had that really early runoff event and we saw really, really high nitrogen losses. So, and this was mostly made up of ammonium. So very high ammonium losses up to 80 milligrams per liter where we had the more solid manure applied. Versus in 2019, in both sites, Minnesota and Wisconsin, there was a long period of time between when we applied the manure and before the first runoff event that happened in March. So in that case, we saw much lower nitrogen concentrations in that runoff water, especially in Wisconsin. You can see it was very, very low, less than 5 milligrams per liter compared to Minnesota, which had up to 20. But then compared to Minnesota in 2018, those concentrations were very low. Here is our dissolved phosphorus losses. This ranged from 0 to 12 milligrams per liter, so a lot lower phosphorus concentrations. What was interesting is there's different patterns, and it might have been due again to those different melting timings. In 2018, we had that melting event that happened almost right after application. And what was interesting was that low solids manure, the stuff that really sunk into the snowpack, had the most dissolved phosphorus losses by far early in the season compared to the high, which was kind of more of at a medium level, about 6 milligrams per liter. They were similar at later runoff events. And then at the last runoff event where we actually had rain on top of the snow, it seems like the manure that was on the solids had finally gotten to the bottom, and then that rainfall had actually dragged some of the phosphorus out of that snow or out of that solid manure pack, compared to we had already lost a lot of it in our low solids manure that had flushed out early in the season. So that was kind of an interesting dynamic that we had. Now, where we had the melting events that happened a lot later in the season after we applied manure, the high solids content manure tended to have more phosphorus losses, at least when it comes to concentrations. Now, the one thing I do want to point out is that, remember, we had a manure that was pretty high solids content and we diluted it to get the lower solids content. So technically what this means is that we actually applied a lot less phosphorus and nitrogen in the low solids and medium solids manures than we did in the high solids. So that's something to keep in mind here. We tried to apply the same rate, about, in this case, it was 1,600 grams per little block that we applied it to. But it was lower concentrations of nutrients overall. So one of the things that we did is we looked at how much nitrogen we applied compared to how much nitrogen was lost at the end of the season. So that's what we see on this x-axis from 0, or y-axis, from 0 to 100%. For phosphorus, it was only up to about 50% lost. And we compared that to the total solids content in the manure. And what you see is that there's a lot more variability and a lot higher losses where we have lower solids content compared to where we have a higher solids content. So what this is basically showing us is that the lower solids contents, where you have more liquid manures, are much more likely to lose much more of their nutrients than the solid manures. So this kind of gets us back to, like, if comparing apples to apples, if we had had the same amount of nutrients applied in a high solids content manure and a low solids content manure, we would have seen a lot more nutrients coming out with those low solids. We think that some of it has to do with because the low solids contents mix with that snowpack a lot more, and therefore more can run off, versus the low solids kind of sit on top of the snow and don't interact with it as much. And then if it's like a nice slow melt, it can hit the soil, interact with it, and then not as many of the nutrients are lost. But of course, like Dan mentioned, every winter is different and every snow melting period is different. So we might see, differences across seasons, but this is interesting that we did see this trend across 3 sites and kind of 3 different kinds of melting periods at each of those sites. For phosphorus, we saw the same thing. A lot less phosphorus is lost, only about 50% of total that was applied, or up to 50%. But there was a lot more lost with the low solids content manures than there was with the high solids content manures. So 2 things that I kind of want to summarize some of this data with is that, 1, if you're applying right before a melting event, you're going to get a lot more losses. For the nitrogen especially, we saw that was the case. And we think that's because, there's less volatilization losses if you're having the melting happening right away. So that nitrogen is going to be taken away with the snow rather than through the air. But we also did see that with phosphorus as well. We saw a lot more phosphorus lost really quickly after we applied the manure compared to later when we had later melting events. And the second thing is that the solid manures seem to lose less of their total nutrients than the liquid manures do. And that reiterates some of the state rules. And I know Dan talked about Iowa, where you can't apply liquid manures. And we have similar rules in Minnesota where you cannot apply liquid manures to snow or frozen covered soils if you're an NPDES permitted facility. And this kind of just shows that maybe that was a good decision in these cases. So that's all I have. Special thanks to my staff and students. There was definitely some days where we were out there and it was below 0 and we were trying to get all these soil samples and chipping water out of the buckets. So big thanks to them for helping me get this research done. Here's my contact info. Follow me on Twitter. I'm at ManureProf. And if you're interested in seeing any of our other research projects, we are side dressing liquid manure into corn during the growing season. We're also looking at manure in a sugar beet rotation. Some of that information can be found at that link here, where we have some story maps walking through those research projects. I think that is all for me.
Okay, great. Thank you, Melissa. And, the reason we call this our speed networking webinar series is because, we give you a tease of what some of these folks are doing across the region. And Melissa gave us even a little bit more of a tease there. So to go find out more of what she's working on. We will move on now to our final speaker. Let's see. Okay, are you guys seeing the right screen there? Excellent. Okay. So our final, did it just go funny on you? Yeah, that's so weird. All right. Okay, let's try that again. So our final speaker, Todd Troyen, is a natural resources engineer in the Department of Ag and Biosystems Engineering at South Dakota State. And he also, in addition to his manure work, he also works on subsurface drip irrigation as a way of applying effluent in a more focused area from animal production facilities. So, and remember to upvote those questions that you want to hear. Make sure we have answered. So please go ahead and do that. And with that, I will stop sharing my screen and turn it over to Todd.
Very good. Thank you so much, Rebecca. And thank you to Dan and Melissa also for good work. I'm going to breeze through a little bit of stuff here, and the first slide is all the people that preceded me here, and really what I'm doing is wrapping up some final data analysis here into a package, and these are the folks that did the work involved with all of this. We got faculty and researchers on the left and graduate students on the right, and you'll recognize some of those names to be sure. And so certainly the acknowledgements to all their good work here, and I hope I can represent it appropriately. So I'm going to step through 3 or 4 different studies here. We'll start with the first one, starting with some basic phosphorus movement in runoff, and working with some small 1 by 2 meter plots at various field sites. You see a rainfall simulator here, applying simulated rainfall and then catching the runoff, and doing this for various soil series with a history of manure application or right next to an animal operation. And here we see 5 soil series. They ended up with covering 8 different series, but you can see, some really consistent results across soil series here. Some very high soil phosphorus test levels, right? Over 300 parts per million Olsen P. So they have a history of manure on some of these sites. A thing to note here, this 100 ppm at the time was the level above which we would have recommended no further phosphorus application to that field. And so that test level would result in this study then would result of runoff with a concentration of total dissolved phosphorus of maybe 0.4, or a little bit greater. So just want to put that little thing in your mind here, 100 parts per million Olsen P, maybe 0.4 total dissolved phosphorus in the runoff. Okay, so those plot studies at various field sites. Then at the same time, in parallel, doing some lab work here with the same soil series again with repacked columns. These are about 4 feet long, about 8 inches wide, and 3 inches deep or so. And then using the same rainfall simulator and catching the runoff from them again. And very similar results. In fact, here's a summary of the field measured total dissolved phosphorus concentrations in the runoff compared to the lab work there, the indoor runoff from those smaller constructed plots. And so that's not quite a one-to-one regression there, but it shows that we can use either one and represent things fairly well either way. So there's the plot work of just pretty straight phosphorus movement with runoff. Then there was 1 year of manure application and snowmelt, measurement of phosphorus movement in the snowmelt. And in this case, we had 2 meter by 2 meter plots. And when I say we, I mean my predecessors, of course. And manure was applied either in November or January or March. Those were the treatments along with the control. And there was 1 season run there. I'm not going to try to untangle those results. I'm going to point you to the publication that just was published in the last couple of months here. So you can go there and take a look at it. And so I won't spend any time on it, so I can spend more time on this. I have lost a slide. There's the slide I want. And so we have a paired watershed field study now is the last bit I want to talk about here. We have 3 watersheds in this field. The field had been farmed uniformly until this study began. And then 3 watersheds. This east watershed is the control watershed, received only commercial fertilizer. The north watershed, the blue, received manure on the lower half, the lower elevation half of the watershed, so closer to the outlet. Here's the outlet for that watershed. Compared to the south watershed then here in green, where the manure was applied to the upper half of the watershed. And then the lower half, any place on this site that didn't receive manure then received commercial fertilizer at the same rate. So we essentially have a setback here, right? In the south watershed where we're applying manure only to the top half, the higher elevation of the watershed. So we ran this for multiple years. Here's a quick overview of the manure applications. You see our applications tended to be later in the season. A lot of Februarys and Marches there. In fact, they're all Februarys and March except for that April that they got lost. And so corn soybean rotation, so up and down at the phosphorus rate here. And I just show the tons per acre. And of course, then the conditions vary, as you might guess. So 2 consecutive years here, one with pretty good snow cover and one without. And of course, that's hit and miss then, whether we had snow or not and how things would work. A quick note about data collection. Early years, we used actually a stage recorder on the left here and had to travel to the site physically to collect manual samples. And that worked okay. We had a really diligent graduate student at the time that would make that 30-minute trip or so from campus to the site, and that worked well. And then later we replaced with an auto sampler, ultrasonic depth sensor, and much more automation. So very quick view on results. I'm not going to go very far on this because we are in the middle of putting this together into one big package, but I want to show you a little bit here now. Total dissolved phosphorus in the runoff for 4 different years, and recall that early slide then where if we had 100 parts per million Olsen P in the top 2 inches, then we'd only have maybe 4 or 5/10 of a part per million of total dissolved phosphorus in the runoff. Well, here now that first year we were up in the 14, 15, 16, 17 parts per million total dissolved phosphorus in that runoff. So, and from the north and the east in particular. Now that east, recall, was the control watershed. So that's commercial fertilizer coming off there and not necessarily manure. Well, not manure. So very early on, we have much greater phosphorus movement than we would have expected from the early plot work and lab work. And again, we still we see greater values than we would expect, but like in 2013, it's only 1.5, so it's closer anyway. So did we have really high phosphorus soil test levels then causing this? Not so much. And I want to move ahead here. There we go. So these are the phosphorus soil test levels, Olsen P from 2008 and 2012. So at the beginning of the study, you see a little hot spot here near the outlet of this north watershed. But even those pink areas are only in the 50-ish range for Olsen P in the top 6 inches in this case. The vast majority of the watershed is down in the, 5, 10, 15 parts per million. So not excessive soil test levels at all. So there's something else driving the big phosphorus loss in the manure. So that's what I wanted to talk about and give you just a little taste of. Sorry, I do not have some nice, neat conclusions to wrap up and send to you here. The best I can do here is point you in the direction of some resources. Advisory board over the years provided wonderful input, financial support, of course, from many different places. And then I've got some publications you can check out here in the slides. You can go back and take a look at them at your leisure. So with that, I will end my share, and I thank you for your time and attention. I will send it back.
Well, Todd, thanks so much for the preview, and thanks so much for going back and diving into that data. I mean, we know sometimes there's data out there that is not being utilized or that we aren't able to access. So it's great to know that you're taking the reins on that. I am now, so let's see. Okay, so why don't we just go ahead and take questions in this format, and right before the end, I'll share the contact information of our speakers again. And you can, we have some questions that were coming in later for Todd and Melissa, so go ahead and upvote those if you really want to hear the answers to those questions. So I will start. Our first question is from Doug, or one of our more popular questions is from Doug, asking if perennial buffer strips have a significant impact on nutrient loss during catastrophic events. So I think all of you could answer that, although I think it started coming in during, Dan, your presentation.
I'll jump in then. I think when we looked at Todd's presentation and his data there, right, he did something, it didn't have a perennial buffer strip, but it had setback versus no setback. When I was looking at his graph there, you could see a pretty significant reduction in concentrations from the setback, especially in that first year, if I recall correctly. And I think that makes sense, right? If you're closer to the watershed outlet, we're getting not only the snow melt, the water melt down where the manure is, but also all the upland waters running through where that manure is, and we're just getting a compounding effect that's picking up more. And I would expect to see the same sort of performance from a perennial buffer strip, right? It's an area where we're not putting manure on, so we have some buffer, some setback distance to help us out. Now, how significant it is during catastrophic events depends on how big your buffer strip is and how much water is there to help you out and get some dilution, right? So I think they can be effective, but a thing to remember is what Todd showed us is a lot of that nutrient in Melissa as well. A lot of it's ammonium, a lot of it is dissolved reactive phosphorus. And the truth is we're probably not going to get huge amounts of infiltration and say, well, the problem went away, but it is certainly a helpful tool, and it's better than not having a setback. It's better than not having a buffer strip.
Yep. Any finer points to put on that, or should we move to the next question? Okay, we'll move to the next question. So Taro has a question about the relationship of some of your findings on winter manure application recommendations related to its impact on groundwater. So if you're considering groundwater impacts, do any of these recommendations change?
From my standpoint, the surface runoff is a much bigger risk for us. When you think about, and this is a poor rule of thumb, but it takes 10 inches of snowfall to make an inch of water, right? And I live in Iowa, so I get to say, oh, my state is basically tile drained. But the truth is we don't see much water movement in tile lines during the winter, right? Because that water gets frozen and held up there. And we will see more in the spring, but that's driven as much by precipitation events in the spring, as well as a high general groundwater table, as it is from snowmelt runoff. And what I tend to think of is when we're thinking about groundwater there is how much water am I really putting into the ground with this snowmelt or winter precipitation events? And it's not really large amounts, right? And you can sort of start doing some math on what's my soil's water holding capacity, how wet is it going in? And we tend to have room if we can get that water into the ground. So I'd much prefer that water into the ground where the ammonium reacts with the soil. It will stick there at least until it's nitrified. Luckily, it's cool in the winter and we don't have as much nitrification. And the same with phosphorus, right? That if we can get the water into the soil, we're much better off. So from a groundwater perspective, I'm going to give you the same recommendations. I want those nutrients to stay in the field and get into the soil.
Yeah, Melissa, and you may, some of your data showed that less nitrogen runoff, I think, toward the end of the season, or and you alluded to maybe some of that is being lost to the atmosphere. Some of that, do we know about the amount that's going up into the atmosphere and the amount that might be headed into the groundwater?
I don't think there's been as many studies on ammonia losses in the winter, though there was one that was recently coming out of New York where they found that during these freeze-thaw cycles, they actually did find some ammonia volatilization more than they expected, because we always think that, it's frozen, therefore gases aren't forming. But because this is volatilization is primarily a chemical reaction, as long as it's slightly warm enough. And when you have a dark manure that's sitting on the surface and it gets heated up by the sun during the day, that could be warm enough to cause some volatilization happening. So I don't know if we know percentages and how much is coming off, because I believe that study was done, like they took some soils that had manure applied and then took them into a lab and did some freeze thaw. So we don't know necessarily if it would be similar in natural conditions or not, but we do know that it happens. So it's hard to say how much is going up into the atmosphere versus how much is running off, but we do know how much we applied and how much we saw in the runoff. And it definitely was higher when we had a closer runoff period to where we applied versus where it was later. So we think some of the other losses probably did happen, like gaseous losses, et cetera.
Okay, thank you. I am going to head to, there's a couple questions here about shoulder periods, like, so Jim Bauman asks about the discussion of winter manure, maybe not considering November or April, and talking about his experience in Wisconsin. So just any thoughts about that November, April, those shoulder periods, and what that means for, quote, winter application of manure?
For Minnesota, the rules are that if you can get it applied into the ground, injected or incorporated, then that's better than waiting until it's frozen or snow covered. And I generally agree with that, because as Dan has mentioned multiple times, getting it in contact with the soil is your best bet for kind of trapping that ammonium as well as the phosphorus. So as long as you can get it incorporated, the shoulder seasons, I would go for the shoulder seasons rather than on top of frozen conditions if possible, if you can get it incorporated. If you can't, if it's still frozen, then avoiding those periods is also kind of the other side of the coin, at least in my experience.
And I'd echo that. I think that's the reason we talk about shoulder seasons differently, is our premier best management practice, injection incorporation, is available to us in shoulder seasons. But I think that is one of the reasons why when we have a conversation about should fall manure application be banned in Iowa, the discussion becomes that April tends to be a wet month down here. And it can be challenging from a logistics standpoint to be in the field, but it also can be a challenging period from a hydrologic standpoint of all of a sudden we already have tile drainage going on and we're going to flush relatively large amounts of water both onto the soil for potential runoff and for movement events. With that said, all the spring manure application I've done research on, I've had much better luck getting good corn yields than being early in the fall. So I'm a proponent of spring manure, but there are challenges that come along with it.
Unmute. We did have a question here about pathogens, and I think it was Dan, your presentation did talk about E. coli, but also that the cold freezing weather challenge for E. coli is different than other pathogens. Could you say a little bit more about that?
Not much more intelligent about that. I think that's an area where, amazingly enough, I think bacteria have been sort of a black box, right? We've picked indicator bacteria and we've hoped like heck they tell us something. I think there are tools nowadays with genetic fingerprinting of bacteria that tell us maybe they were or maybe they weren't always as good of choices as we want. And I'd like to tell you that I can look at my reference book and find which bacteria will die or won't die in freezing conditions. And we don't have that reference book. So I think that's an area where, as we continue to look at the future of maybe some manure studies, especially related to winter, we'll see a lot more discussion and a lot more conversation, because when it comes to bacteria, it's probably not coming from anhydrous ammonia or other synthetic fertilizers. It's probably a manure, wildlife, or a human sewage issue.
Okay, all right, thank you. Ellen asks a question about I think the relationship, I'll say the relationship between winter cover crops, manure benefits, and water quality. So, anything more to say about opportunities or trade-offs there with winter cover crops and winter application of manure?
From all the work I've seen, cover crops in general are a good thing for helping with nutrient control. The one thing that you could potentially watch out for, and rarely in my manure site, which is in northern Iowa, is this a problem, but a lot of cover crop growth in the fall could lead to more snow capture in the field, and that would be something I'd pay attention to. On the other hand, my cover crops are nice and miniature yet in the fall, and that's not something that I've had too much concern for. I think Melissa's done some great work with injectors and how low disturbance injectors really help cover crops thrive. And I think I'm a big proponent of get your manure in the ground. So that'd be my only other comment, is low disturbance injectors still can give you good injection if you're at appropriate rates.
The only other thing I'd watch out for is, and I think this is research coming out of Canada, where they had some manure applied on top of, or during the winter on top of alfalfa. and they had a high salt content, and that actually burned the alfalfa. So the strips where they had manure, like the alfalfa was burned, and then the strips where they didn't have manure, the alfalfa was coming back just fine in the spring. So if you're worried about that, that might be something to do, is test the salt content of the manure just to see if it will be problematic.
Okay, great. Thank you. Dan asks a $1 million question here, which is, given the current widespread poor state of water quality in Midwestern streams, rivers, and I'll add lakes to that, what right-sized rules, if you have any thoughts about that, might be needed to fix the problem? We know there's some, it depends, but we know there's some things that we know would help. So any thoughts about that?
Number one, recognize that it isn't just a manure challenge, that when we talk about water quality challenges, I think it's important that all fertilizers come to the table in the discussion, right? I'm a big fan of cover crops. So I would say pushing cover crops, especially I'm a proponent for early, if your manure goes on early, and would define early different in every state. So I'm not going to be hammered down to give you a date, but early manure probably should have a cover crop to help soak up some of that nitrogen. I think many states have made winter manure application much more difficult. And the truth is, I think higher fertilizer prices will continue to push improved nutrient management and utilization. And I think we're seeing that with more interest in how can we move some of this manure to in season. And I think that's a good thing. And that's probably how we want to fix it. I think saying today that I want all manure legislated to be in season is a huge challenge. I think we haven't demonstrated enough technologies to make that achievable, but I think that's the direction we have to continue to push with maybe some of our legislation. That and cover crops.
Yeah, I agree. I also think I've seen some states where they have a lot of successful programs for helping with cost sharing, for building more manure storages, to make sure like that way we don't necessarily have to apply during the winter, or thinking about transferring manure to places where it could benefit the fields more. For instance, if you have high P fields and you want to take your manure further out so they can get away from building soil test phosphorus even higher, that can be beneficial. So certainly seeing more cost share programs would be helpful as well.
Put in a quick plug for irrigation systems for applying liquids when you can, because then you get really good control in timing and placement.
Okay. And while I switch slides here, we had some questions about, the impact of slope and the shape, and even the shape of slope. So, concave slopes versus convex slopes. Let's see. Did you look at the shape of slopes, and also, anything more to say about the impact of slope?
Yeah, I don't have that information from our studies. I don't believe we have enough variation of that to be able to say anything definitive about it.
The only thing I would say is convex versus concave. On a concave field, that you're going to look like you have a grass waterway at the bottom. You're going to get an area of concentrated flow. Try and avoid that with your manure application and treat parts of the field differently, right? And convex is interesting because I want to apply in the middle where it's high and dry, and I probably want to avoid as I get closer to the edges, because those are probably near a ditch where, as Todd showed in his watershed study, if I don't have that setback distance, I'm putting dirty water right in the ditch. So I think part of it, as unappealing as it may be, is we don't get to go out and put manure on the whole field. We have to have management zones where part of a field might be good for, better suited for winter manure application, and part of the field you may have to wait until a different season and be filled in later.
Okay, really, really helpful. Thank you so much for excellent presentations. I know we have other questions that are unanswered. That's why we provide you with our presenters' contact information. Thank you. Please, they've graciously agreed to help follow up on some of these questions. And I'll just close. We know that manure has benefits for soil health and benefits for agriculture generally for carbon. But we also are facing these challenges. So we really appreciate our presenters helping us to sort through some of the opportunities and challenges. We have some other events coming up here, 2 upcoming webinars from our soil health and climate teams, Climate Smart Agriculture for the North Central United States, Wednesday, February 23rd at 2 p.m. Central, and also takeaways from COP26, Monday, February 28th at 1 p.m. Central Time. We appreciate you joining us today. Thank you so much. And thanks again to our presenters for their excellent presentations.